I'm Alex St. John, Nyriad's Chief Technology Officer, and today we're going to show you another exciting feature of Nyriad's Ensilate storage processing technology. So today we're going to show our Amazon S3 compatible interface running on Ensilate. And what we're going to do here is, of course, those of you familiar with Amazon know that we can store data on it. So let's store some data in our S3 compatible instance here. So we go up here, we get a river video, drag it into the folder, and drop it. Now, if we were in the storage business, this would be the end of the demo because that's what storage things do, is store stuff. However, Nyriad does something very different here. We use a powerful graphics processing unit to do all of our storage processing, which means we have several teraflops of parallel processing power we can apply to all the data that's being stored. So we can do something interesting, for example, like attach a video player to this file. And now all files stored in this bucket will, if they're videos, can play. So in this example, we've got a lovely boat video here with some people and dogs walking around on the screen. And that's a good example of being able to attach a program to an object in a storage array. But we're going to do something interesting here. We're going to attach a very different kind of program. Security is one of the most significant and important issues in storage today. And there's been major technology advances in security architectures very recently. One of the most interesting ones is blockchain technology. Now, most of you have probably heard of blockchain in the context of Bitcoin. Lets you exchange money efficiently and prove that whoever gave you the money actually had legitimate currency. Well, what you're about to see is a blockchain storage system. Means that all data stored in the system can prove who put it there, how it was used, and that it is genuine, and leaves a complete audit trail. So we're going to attach our blockchain auditing program to our video. And over here on the right-hand corner, you can see the blockchain history of this object. There's the original hash code, there's the metadata, the user who installed it here the very first time, and then when we played it, there's the first get. But you'll notice there's a little Bitcoin logo up there in the corner, and that Bitcoin logo is attached to the blockchain ledger for Bitcoin, and we have reported all of the information stored in this array to the Bitcoin ledger. So when we click that logo, the blockchain ledger verifies that everything we know about this history is correct. So all of this data is legitimate, and the public blockchain ledger can be used to audit and prove that this has not been tampered with. Now we're going to allow a malicious hacker to break into our storage array, which is, heaven forbid. This hacker is a worst case scenario. The hacker has root level access to the file system. The hacker also has all of our passwords, our encryption keys, and knows exactly how our storage array works. So the hacker is going to break in, remove all the encryption from these objects using the encryption keys, and they're going to change one bit in this 10 megabyte video, just one bit. And then they're going to put everything back in place so that our technology, or our storage array, can't tell that that data has been hacked. So here we go ahead and corrupt one bit. There we go. So we broke in, removed the encryption, corrupted it one bit. All right, now let's go back to our array here. We're going to go to the blockchain ledger and give it a click, Bitcoin, and we audit the data in this directory, and no, the blockchain ledger reports that a malicious hacker got in there, tampered with the data, and the data has changed by one tiny bit. Now the interesting thing is if you actually attach a video player there, we only changed one bit. Corruption of one bit happens all the time in storage arrays. Most people never notice it. So in this case, the video, if you looked at it, looks perfectly fine and normal. There's nothing you can visually distinguish about it. But the blockchain history detected that one single bit had changed and reported it to us immediately so that we can restore it.